Hi, welcome to the Olympiad geometry. Let's continue our study. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe to the channel. So today we are going to keep our discussion on the geometry treasure. We're going to talk about the common angle theorem, and we're going to prove the angle bisector theorem. First, let's look at the common angle theorem. If angle ABC equals to angle A prime B prime C prime, or angle ABC plus angle A prime B prime C prime equals to 180 degrees, then the area of triangle ABC to the area of triangle A prime B prime C prime equals to AB times BC to A prime B prime times B prime C prime. Okay, so we would have several cases for the first problem set, because for the triangle ABC equals to triangle A prime B prime C prime, so we can put them together, right? We have two different ways to put them. The first one would be point B is here, C is here, A is here, A prime, C prime, so B is B prime, right? That's the first way we may have. And the second one we may have would be this case, right? Now let's prove each one. So think about the area of triangle ABC to the area of triangle A prime B prime C prime. We can always connect AC prime, right? So it equals to the area of triangle ABC to the area of triangle area of triangle ABC to the area of triangle ABC prime. Right here, ABC prime, and times the area of triangle ABC prime to the area of triangle A prime B prime C prime, right? So for the first case, it's ABC to ABC prime, and then ABC prime to A prime B prime C prime. And for the second case would be ABC to ABC prime, and then ABC prime to A prime B prime C prime, right? So for each case it's the same, so I combine them together. It will be AB to BC prime times, well, let me see, it's actually BC, right? BC to BC prime times AB to A prime B. So it equals to AB times BC to B prime C prime times A prime B prime. Okay? So that's for the case that angle ABC equals to angle A prime B prime C prime. And for the case that angle ABC equals to angle A prime B prime, plus angle A prime B prime C prime equals to 180 degree, right? The angle ABC and angle A prime B prime C prime are complementary angles. So we can have this way that still connect to the angle, connect to the AC prime. Then we have the area of triangle ABC to the area of triangle A prime B prime C prime equals to the area of triangle ABC to the area of triangle ABC prime first times the area of triangle ABC prime to the area of triangle A prime B prime C prime, right? So for the first case, that ABC to AB prime ABC prime, that equals to BC to BC prime. And for the second case, that ABC prime to A prime B prime C prime, that is AB to A prime B. So it equals to AB times BC to A prime B prime times B prime C prime, right? Okay, that's for the first part, and we want to also derive the converse of this theorem. I would leave this to the audience. It's pretty easy based on this one. Use the same figure. It's just saying that if this is valid, if in two triangles, if this is valid, then you need to prove that angle ABC equals to angle A prime B prime C prime, or the angle ABC plus angle A prime B prime C prime equals to 180 degrees. Okay. So for the second one, that if ABC equals to XYZ, or ABC plus XYZ equals to 180 degrees, and P is a point on line AB. So let me just draw the figure, but I will use a more complex case that the angle ABC and angle XYZ. ABC is here, XYZ is here, right? So the angle ABC is supplementary angle to the angle XYZ, and P is a point on line AB. So here is P, and Q is a point on line XY. So this is Q, right? Now we want to calculate for the area of triangle PAC, which is this one, to the area of triangle QXC, right? QXC would be this one, right? So we can think about that area of triangle PAC to the area of triangle QXZ, it equals to the area of triangle PAC to the area of triangle ABC first, right? And then we calculate for the area of triangle ABC to the area of triangle XYZ second, and then we calculate for the area of triangle XYZ to the area of triangle QXZ, right? So it equals to C, the area of triangle PAC to ABC, that is PA to AB, right? The area of triangle ABC to XYZ, because we already know that angle ABC plus angle XYZ equals to 180 degrees, so we can directly write it down. That's AB times BC to XY times YZ. And for the area of triangle XYZ to the area of triangle XQZ, that is XY to XQ. So, wait, it equals to PA times BC to YZ times XQ. Okay? So you can look at this one, and here, this one. We just prove it, right? Okay, finally, let's do some more advanced improvement here. That in triangle ABC, D is a point on edge BC, or its extension, right? So this is triangle ABC. D is a point here, or on its extension, right? So let me just draw D here. If BD to DC equals to AB to AC, then AD is the angle bisector of angle BAC, or the angle bisector of its supplementary angle. Okay, so first thing we can use that we already learned about the common angle theorem, so we know that the area of triangle ABD to the area of triangle ADC, right, equals to AD times BD to AD times DC, which equals to BD to DC. And we already know that BD to DC equals to AB to AC, right? Which means we can translate it to AB times AD to AC times AD, right? That means for the triangle ABD and triangle ADC, we can have the ratio as AB times AD to AC times AD, which means that angle BAD and angle DAC either equal or supplementary, right? If angle BAD equals to angle DAC, then AD is angle bisector of angle BAC. If angle BAD plus angle DAC is 180 degree, that means AD is the angle bisector of the supplementary angle of angle BAC. Right. Okay. So in this video, we shortly review the theorem called common angle theorem, which we get the area of the triangles based on their edge ratio, just because one of the angles are equal, right? And based on that, we derive the angle bisector theorem. Okay. I hope you like this video. See you in next one. Thank you.